Okay, guys, it is Friday, April 3rd. We are in Algebra 2, Mod 8, of course. Like we've been doing, I suggest or ask that you get out a clean sheet of paper. Everything away, but this paper, something to write with, and hopefully you've got the ability to focus on 3 questions I'm going to do today. Big deal, 3 problems. So in the top left corner, April 3rd, 2020. The title, instead of just simplifying rational expressions, notice says multiplying rational expressions. So put that title at the top, multiplying rational expressions. And our first problem, again, there's only 3 of them today, looks like this. Okay? X squared minus 16 over x squared, dot connected, or times x squared minus 4x over x squared minus x minus 12. So instead of one fraction like yesterday, and we tried to simplify that one single fraction, we're now multiplying 2 fractions together, and we want to simplify the expression that we get when we're done doing this problem. First piece of advice. I know that the easy thing to do would be to look at this, and a lot of you would think, oh, I see an x squared over here and an x squared down here. Let's cross cancel those x squareds. Guys, there can be no cross canceling of anything until each expression in the problem is factored and turned into its own little dot connected situation. Here's what I mean by that. Does everybody agree that this x squared minus 16 in this numerator, if it was the only thing sitting here on this paper, couldn't you factor that or break it down into 2 binomials? Think about it. That's called the difference of 2 squares. X squared minus 16 should look familiar. You factored that earlier this year into what? I'll let you think about that for a second. Wouldn't that factor, into x plus 4 times x minus 4, right? The x squared is x times x. The minus at the end meant my signs were different. And for that 16, we have a 4 times 4. Now the bottom, of course, is just x squared, and there's nothing we can do to that. That is dot connected to the second fraction. And once again, I challenge you to look at the numerator only of that problem. Do you agree that x squared minus 4x, they have an x in common, right? So again, factoring that, since they have an x in common, I'm going to factor out a GCF of x. And if I factor out an x, it leaves me with x minus 4. Agreed? And on bottom, that's just a nice, normal trinomial that we're used to seeing. And any trinomial, of course, we try to factor it and break it down into 2 binomials. X squared would be x and x. I have a minus at the end, so my signs are what? Different. A plus and a minus. And for 12, wouldn't I use 3 and 4 in that order? Because a positive 3 and a negative 4 combine together to give me a negative 1 that's found in the middle. So I factored it correctly. So advice number 1, take each individual component or value and factor it in itself to see what now we can start cross-canceling. Because if they're now all dot-connected factors, we can cross-cancel anything that happens to identically match. So it's pretty obvious. This x minus 4 down here will cancel with that x minus 4 there. I've got an x up top that'll cancel out with one of the x's down here, leaving me with just an x. It'd be nice if there would have been an x plus 3 on top that would have canceled out with this x plus 3 on the bottom. We could have got rid of those, but they don't match. Therefore, technically, the answer to this problem, really, if the dust settles, what's left standing, I've got an x plus 4 and an x minus 4 on top, agreed? Down below is just an x and an x plus 3, and that's my simplified answer. So I indeed multiplied two rational expressions. In essence, you're factoring everything in the first fraction, factoring everything in the second fraction, and canceling out any factors that match up. So if that's technically all we're doing, let's give that a shot on problem number 2 here. You can see what it says. Go ahead and copy it down. X squared minus 2x minus 35 over 2x cubed minus 3x squared times, and then your second expression says 4x to the third minus 9x all over 7x minus 49. My advice, this looks a little overwhelming and a little crazy with all that stuff. Guys, focus on one expression at a time and pretend each expression is its own little problem. So let's take this top trinomial and let's focus on breaking him into two binomials. X squared would be x and x. I have a minus at the end, so my signs are different. And wouldn't I use 5 there and 7 there, because a positive 5 and a negative 7 equal the negative 2 in the middle, right? You got to know how to factor. You've been doing it all year long. Underneath, if you looked at that expression down there on the bottom, and I said, what do you notice about those two values? Don't they both have a GCF of x squared? I'm going to factor out an x squared. And if I take an x squared and factor it out of each of them, that should leave me with 2x minus 3. Agreed? If you have to pause the video and think a minute about what I did at any point, please do so. You're going to learn at your pace. Times, now this expression up here, you'd notice they have an x in common. So I'm going to factor out an x, and that should leave me with what? 4x squared minus 9. Down below, I hope it's obvious that you can factor out a 7, correct? Leaving you with x minus 7. Now, you would love to start cross-canceling things that match, but I do notice one more thing. This was a little bit tougher than normal. Guys, focus on this expression right here. That 4x squared minus 9. Does everybody agree that, remember how x squared minus 16 was a difference of two squares? They were both perfect squares. These are both perfect squares. So guys, you can actually factor this 4x squared minus 9 into what? 2x plus 3 and 2x minus 3. Don't just write that without understanding it. You agree that 4x squared would be 2x times 2x. I have a minus at the end, so my signs are opposite. And for 9, I use 3 and 3, which really helps. Because if I cross that out now and change it to that, it's pretty obvious that, oh my goodness, the x minus 7s cancel. The 2x minus 3s cancel. This x cancels with one of the x's down here, just leaving me with an x. So when the dust settles and I say, what's my final answer? The numerator would have an x plus 5 and a what else? A 2x plus 3. The denominator just has a 7 and a x. And that becomes my bottom value. Wow. I've multiplied and in essence simplified my rational expressions. Not easy. That's why we're only doing 3 of these today, just to see if the process makes sense and you can start to get the hang of it. Okay? Finally, problem 3. You can see it in front of you now. Once again, my advice is simple. Break the numerator down, break the denominator down, break that numerator down, and break this denominator down. When I say break them down, I mean factor them as if they were all individual problems. So here we go. This first numerator, you would agree, is a nice normal looking trinomial. So when I go to factor him, x squared would be x and x. Minus means my signs are different. And we'd use what? 2 there and 3 there, because a positive 2 and a negative 3 gives me the negative 1 in the middle. So guys, just focus on one expression at a time and pretend you're doing it like we've factored and done problems in the past this year. Now on the bottom, of course, there's nothing you can do to 4x to the third, but sit there and leave it alone. This next group after the times sign, oh, look up top. Now there's not a third number, is there? So you're not factoring him into two binomials. You're just going to factor out a GCF of, wouldn't it be 2x? I can factor a 2x out of each of those, and if I do, it leaves me with x plus 1. And down on the bottom, I'm going to factor this trinomial into x and x. The signs, since that's a plus at the end, are the same, both positives. Now careful, don't use 6 and 1. Wouldn't we use 3 and 2? Because 3 and 2 add up to the middle number of 5. So if you're a good factorer, you should be able to factor each expression individually and then cross out everything that matches. Sometimes that's a lot, sometimes it's not. So this x plus 2 cancels with this x plus 2. Boy, it'd be nice if that would have said x plus 3, because then it would have canceled with this x plus 3, but it doesn't. I'd get rid of the 2 and change that 4 to a 2, right? And finally, this x would cancel, and if I get rid of one of these x's, I've got 2 of them left. So again, when the dust settles and I say, what do you got left standing there for your final answer? We've got an x minus 3 and an x plus 1 up top. Down below, we've got a 2 and an x plus 3. And my answer simplifies to that result right there. You never have to distribute or multiply. Once you get to this step, and everything is in its simplified factored form, you're good right there, okay? Remember, if for some reason you don't seem confident in trying your homework problems yet, or you get stuck on a problem or two and need to watch this video again, that's what it's there for. You can always go back, watch it again, fast forward or move to the places you need and want to see the explanation a second time. And that's how you're going to clear things up and answer your questions. Focus, listen to me, follow with the steps. And I hope this is working out okay. I'm doing the best I can, guys, explaining and trying to keep things simple and taking it one topic at a time without trying to overdo it. I hope the 15 to 20 minutes a day is not too much to ask. Since today is Friday, April 3rd, your 3 homework problems are not due till Monday, April 6th at noon, just like every other assignment. You certainly can take a picture and email it to me and turn it in as soon as it's done, anytime you want to. I'm just saying the due date for this will be Monday, April 6th at 12 o'clock, okay? So again, Algebra 2, the date's 4-3. Your homework are these 3 problems right here. I'll give you a minute or so to copy all 3 of those down. Notice they are all dot-connected multiplication problems, and my advice on all 3 of them is to take each individual expression and factor it as if that was the only problem on the whole paper. Once each of the 4 are factored correctly, you then cross-cancel anything that matches, and whatever's left over is the answer to your problem. So in theory, it's not that bad, and your job is to take your time, do the best you can on these 3. This will be your daily grade for this assignment. You get a point or 2 for trying, a point for the right process, and then a point or 2 for the correct answer. And we've got to give you a daily grade evaluating your work for correctness on a daily basis. And at the end of each week, you'll have a weekly grade that comes from, of course, adding together all those daily grades. Okay? Great job. Hopefully we'll see you on Monday.